So welcome everyone to this session called the end of polling. So we'll see together why and how you should consider transforming your REST API into a data streaming API. So quickly to introduce myself, my name is Audrey Neveu. I'm developer relations at streamdata.io. I'm also the co-leader of Devox for Kids in France, as you have probably guessed. And you can find me on Twitter with this handle. So modern times. We know that applications that we develop have to be mobile ready. Even businesses want you to bring your own device movement. The problem is that the market application is now completely full. It becomes very, very hard when you launch a new application to acquire users, more even active users, and to retain them. So we know that we have to make our users addict of our application. And we also know that one way to keep our user interest alive is animation. That's the reason why I'm using GIF instead of bullet point. I'm sorry, I know you are all completely mad about bullet points, but it's got to be a GIF presentation. But the thing is, we don't really know why the animation is so important. In fact, it's because of evolution. But when I say evolution, I mean much more older than this one. It comes from this guy there, who has understood one really important thing. If it moves, it can be either two things, food or danger. So in both cases, it might be worth worrying a little bit about. And that's the reason why our brain is so addicted to things that move, because if it stops moving, it considers that it's dead, and there is no interest to looking at something dead, so just move on. Sorry, Kitty. So on the user interfaces part of our application, we already know it for a long time. We got CSS3. Every mobile framework got animated component. I took here React Native and Ionic animation as example, but same for everyone. And the really interesting part there is to see that even in material motion, there is a dedicated part to animation. And one of the reasons why they recommend to use animation is hiding from the user what's going on behind the scene. Because indeed, the problem is when it comes to data. When you want to refresh data, usually it starts with a refresh button, which is not the best way to start our relationship with our users. That's me in front of a refresh button. We know that the less interactions the user have to make to get the data he's interested in, the better it is. So refresh button is really not the best way to achieve this goal. And the problem with refresh button is that usually it comes with the loader screen of the dead. The problem with this screen is that if it stays for too long, the user will be quickly upset and will probably leave the application and perhaps never come back. It looks like it's bugged. OK. OK, it's a connection problem. Damn. Hmm? That's it. It's refresh button. OK. You're supposed to work offline, you know. So refresh button is evil. We should stop using it right now. And in fact, what you need for application is a real-time user experience. If you look at most popular applications on both stores, Android or iOS, you will notice that the most popular applications in terms of active users, but also in terms of dwell time, which is the time users are spending on your application, is those who are completely built upon real time, or at least who are using it for a very long time. I took here as example Uber and Twitter and WhatsApp, but I could also have mentioned Slack or G-Shoot, because it's the case both in our personal life and in our professional life. And there is a reason why we're so addicted to real-time experience. It's because it has created something new in our brain, which is called FOMO, fear of missing out. The fact that those three little dots are dancing in my application told me that something is happening. Something is going to be sent, and I want to know what it is. So I'm staying on my application. Yeah, it sounds a little bit silly, but that's how our brain is working, actually. So basically, what you need to do when you get static, classic REST APIs is streaming them. And when it comes to streaming API, so to make real time on basic API, usually three solutions are mentioned. So the first one is polling. Who knows about polling? Yeah, okay, a lot of people. And it's variant the long polling. I guess a lot of you knows about it too. Yeah. The second one, which is very popular, is WebSockets. Who knows about WebSockets? Yeah, almost everybody. And the last one is server sentiments. Who knows about it in the room? Great. Not that much people. So polling is this. I'm making a request, waiting for the answer, making the same request again, waiting for the answer, and so on and so forth. So that's what's happening in the wonderful world of theory, where we would love to live, all of us. But in reality, what will happen with polling is polling madness. In fact, you will make a lot of useless calls. You will retrieve the same data a lot of time unless you really know at which frequency you have to poll your API. People at Zapier have made these studies that 98.5% of polls they were making were just wasted. So polling is not really a solution on itself. That's the reason why some persons suggest long polling as a solution. So long polling is a small variant where you keep the connection open until the server has new data to send. OK, fine. It can work, but it implies that on both sides, on server and client, you get jobs looking constantly at those sessions open. So it's not really scalable too. And the main problem remains the same. If the connection is dropped for any reason, how are you going to retrieve information you've been missing during this time? And most important, as an API provider, how are you going to deal with all that polls? I mean, if your application became very popular and you get thousands of devices making polling or long polling requests, how are you going to deal with? So polling is not a solution neither, long polling neither, and we should stop using them too. So that's the reason why we created push technologies, WebSockets and server sent events, which are both under W3C specification and appeared around the same period. As you can guess, if both exist, it's because they are quite different, so we're going to see why. So the main difference, I think, between WebSockets and server sent events is that WebSockets are bidirectional. So it means that both the user, the server, and the client can send data to each other. Whereas server sent events is unidirectional. So only the server is able to send data to the client. Second big difference is that WebSockets supports both text and binary, whereas server sent events only support text. So now looking at protocols, WebSockets has its own TCP-based protocol. So its only relationship with HTTP is that the end check is interpreted as an upgrade request. And then the server will switch to a binary bidirectional protocol, which has nothing to see with HTTP anymore. Server sent events on this side completely relies on HTTP. So to use it, you just have to add the header you're seeing there, the text event stream header, and it works. So as you can guess, in terms of configuration, having its own protocol means that to use WebSocket, you need to reconfigure proxies and load balancer. And that's something ops are not really fond of. Actually, there's a good reason why. It's because at first, not every proxy supports WebSocket. And then even in them who are supporting WebSockets, not all of them are supporting them correctly. So it could be a real nightmare to configure your proxy to support properly WebSockets. Server sent events, well, so it's HTTP, so you just have to be sure that your proxy will support long live requests, a long live session, and that's it. Now looking at messages format. In WebSockets, nothing is defined in the specification, so it's up to you to decide what field will be in your message. It's up to you to parse and unparse it too. In server sent events, a message is any line of text beginning with the data prefix. So it can be a single line of text. It can be 2 lines of text or more. It can be a JSON object. Everything works. And the very cool thing there is that we also got a few fields we can add to our message. So we got the ID field, the event field, and the retry field. Keep them in mind. We will talk about them just after. So now looking at implementation. So here I took as example a JavaScript implementation on customer side. It's almost the same in every language, so don't worry about that. The very cool thing is you're going to see it's very similar. They keep the overall idea of the implementation on server sent events for WebSockets. So to create a WebSocket connection, you get to declare a WebSocket object and pass the API you would like to stream as a parameter with the WS or WSS prefix. In service and events, you get to create an event source object and pass the API you would like to stream as parameters too. Then you can register to different callbacks. The first one is onOpen, which can be very useful, especially in WebSockets case, because opening a connection is made asynchronously, and it's really prone to error. So you might be interested in knowing that the connection has effectively been opened before trying to send data from the customer to the server, for example. Then you can register to the onMessage callback. So as we've seen previously, in WebSockets, nothing is defined. It's up to you to unparse it properly. On service and events, you just have to call the data field on the object you got in parameter. Then you got the onError callback. So I guess this one is pretty obvious. I'm not going to spend time on it. But the really cool thing there is that service and events allows you to not only listen to messages, but you can define to listen to arbitrary event. So if you remember the event field, got the same connection problem. OK. It's going to be tough for the drone, but OK. Let's try this one. OK. So if you're looking at the event field we have got there, by adding it to your message, you will be able to add an event listener on those type of message. So perhaps, first of all, perhaps you're not interested by every message sent by the server. So you will be able to listen only to those of them you're interested in. Or perhaps you want to make a different treatment for those different type of messages. So you can do it easily with, by typing your event. What happens if the connection is dropped for any reason? We are talking about streaming, so we have to care about that. Unfortunately, in WebSockets, nothing is defined. It's up to you to deal with. Sorry about that. In service and events, we got two very cool features. The first one is the reconnection timeout. So it means that if the connection is dropped for any reason, the browser will automatically try to reconnect after 3 seconds. If this value doesn't fit for your needs for any reason, you can redefine it with the retry field we've seen previously. And then, if you had the good idea of adding an ID field to your message, the browser will be able to add a little header to its reconnection request, a last event ID. And by giving the last event ID it has received, the server will be able to send all information that has been sent through this period. So now, talking about the sensitive part, browser support. So WebSockets are natively supported for a very long time by every browser. So that's probably one of the reasons why they are so popular. Whereas service and events is only supported by modern browser. So not Internet Explorer, obviously. But actually, that's not a problem, because we got a polyfill. So we can handle both Internet Explorer and older versions of other browsers. For Edge, at the moment, it's under consideration. So we keep hoping, you know. Talking about mobile browser support. So it's the same for both technologies, only Opera does not support them. So now talking about performances. So these numbers are coming from Matthias Nilsson's blog post. So Matthias is the developer of Birdwatch, which is an application where you can search along a stream of tweets in real time. And so his use case was he needed to preload 500 tweets when the application was loading. So first, he made a first implementation with WebSockets, because that's the only technology he was aware about. And quickly, he has a lot of issues on his GitHub with WebSockets issues, actually. So he decided to give a try to service and events, and then make this benchmark to be sure that performance was not impacted. And so first of all, he was quite surprised to notice that there was such a difference between the implementation of the same technologies in different browsers. And he noticed that it was way more efficient for him to use service and events. Actually, the fun part is that it took him more time to write the blog post than to write the implementation in service and event. So as often in development, it's not that there is a good technology and a bad one. It's just that there is a technology for your need. If you want to make a chat application or a video game, yeah, obviously go on for WebSockets. That will probably be better. But if you're going to send only data, only text data, and if this data is going to be refreshed only from the server to the client, probably on the other side, you will be able to just handle data sent, request sent by the client with classic post request. So in this case, go on for server-sent event. That will be way much better. So that's the reason why we built connection queue. OK. So that's the reason why we built stream-data.io, which is a proxy available as SaaS. It works with any JSON API, and basically it turns them into a stream of data. So you're going to open a streaming session with the proxy, and the proxy is going to make the polling for you. We're going to handle everything that goes wrong, and we are going to send you updates with server-sent events. We added a dynamic cache, so it means that if you've got people joining the session between two polls, they don't have to wait until the next one to retrieve data. They can just retrieve the last one from the cache. And most important, we make incremental updates. So it means that, for example, if on the first call we retrieve a snapshot, we will retrieve the initial snapshot of data, a big document with a lot of fields. And on the second poll, nothing has changed. We will not send you anything. There is no point to send you the whole document again, so OK. And let's imagine now that on the third call, only 2 fields of this document have changed. We will use JSON-Patch, which defines a set of operations that could be applied on the JSON document to send you only what has changed. So if this is, for example, the first snapshot of data we retrieved, then on the third call, we will receive this instead of the whole document again, explicitly saying what has been changed and what changes it was. And from this point, we can just use a JSON-Patch library to apply it to our initial document. So let's move to a demo. You've probably seen that I got a drone there, and I would like to make it fly on the Bitcoin value, on the Bitcoin average USD Bitcoin value. So first of all, I'm going to create my application in the developer portal. If I got enough network. OK, here it is. So let's call it Bitcoin. So once the application is created, the token is generated. And I can copy-paste there any API I would like to test to see how it looks like when I stream them. So here I'm going to keep this one, which is one of our internal. It emulates a stock market API. And I'm going to copy-paste this curl command there to see what it looks like. So here my streaming session has been opened. I've received the first snapshot of data. That's my event called data. And then I received only incremental updates, which are my patch events. So once I get that, I can just go back to the My API sections. And so here it has been automatically provisionized by my curl command, but I could have added them manually. And most important, I can configure them. So now I'm going to change the polling frequency first. But if I was having HTTP headers or query parameters, I can put them there. And if I'm coming back to the terminal, so I can see that the polling frequency has already been updated without closing and reopening the stream. OK, so now let's see how it looks like when we want to make a drone flying. So it looks like my IntelliJ has died. Yeah, OK, so we're going to move on to Sublime. Don't know if is it readable for everyone? Yeah. I don't know how to zoom in. Oh, great. Better? Yeah, OK. So here it's a very simple node project. I got only 3 libraries imported. The first one is the event source library. The second one, JSON-Patch. And the third one is the API, the library I'm using to pilot the drone. So first of all, we are going to create a drone client by calling iRdrone create client with an options object, which we are going to define there and say options.ip equal OK. Then I'm going to create an event source object. So let's call it event source and say new event source of API. So I'm going to declare my API there. So the API I'm using is this one, Bitcoin Average API, which I'm going to put there in place of the stream data API. OK. We're going to need a data object and a last object. OK, and once we got this, we can just start listening to some event. So we are going to say event source.add event listener of the first event we're going to listen to is the data event, which send me the first snapshot of data. So I'm going to retrieve a snapshot object. OK. So I'm going to assign it to assign it to my data object. So here I'm calling the data field on my object. And here my last object will be data.last. And so from this point, well, I'm going to log what's going on so that you can see values in real time. So it's going to be last. And then I can say drone.takeoff. OK. So then I can register to another event, the patch event, which is going to send me patches. And here I'm going to just create a temporary variable called patch. Patches.data. And here I'm going to use my JSON-Patch library. So I'm going to say JSON-Patch.apply on the data object, the patch object. And so we're going to log it. So it's our patch last. Data.last. And we can try begin comparing it. So if our last value is under our data.last value, which is the last one I received, it means that the Bitcoin has gone up. So, and we're going to tell the drone to go up at a speed of 0.5. If it's not the case, it means that Bitcoin has gone down. And we are going to tell the drone to go down at a speed of 0.5. And finally, we reassign our last value to data.last. OK. So now we are going to listen to the error event, just in case. Might be interesting. So first of all, we are going to log what's going on. Then we're going to set drone to land, obviously. And we are going to close our event source. And then we're going to make something quite similar, because we don't want the drone to just fly over for the next 20 minutes. So we are going to say drone that after 30 seconds. And it's going to be very similar to this one. Yeah, it's not IntelliJ, so not the same shortcut. So let's say time's up. OK. So now I'm going to share my connection to the drone to make it fly. So sharing. Yep. Stopped. Should be good. So we have to wait for the drone to be ready. Green light, please. Yeah, great. And now we can simply try to communicate with it to be sure that the connection is opened. OK, nice. And so now we are going to. So I'm going to run directly. LS. Oh, yeah, it's me. OK. What's going on? Huh? Oh, yeah. It's not IntelliJ. Thank you. OK. So here we received our first slat. The drone is taking off. OK. Going up. Third one, down. Great. OK, that's the ceiling part where you're jumping on the floor. Yeah. And it's up. So I really hope I convinced you that server-sent events is a nice technology. If it's the case, you can vote for its support in Edge. I will very likely thank you for that. If you got questions, I don't know if there is someone after me, so we got a lot of time. We also got some stickers and postcards and Nerf guns, so grab yourself. Thank you.